Hello everyone. Today we are going to learn about matrix. What is matrix? What is definition of matrix? What are the different kind of matrix and what is the basic algebra of matrix? We are going to learn in today's session. So let's start with our topic matrix. So let's understand first what is the matrix. So for that let's suppose Rahul has 15 book. So how we are going to represent in the form of matrix this 15, Rahul is 15 book, so we will be writing like this. In a rectangular bracket we will be writing this value, this 15 is representing number of books. So see, whenever we are talking about the matrices, we are going to write this rectangular box. In this rectangular box we are going to write our numerical value, it may be functions also. So whenever we are talking about matrix, we are going to write this rectangular box. And in this rectangular box, there will be some values or functions. So let's talk about if there is two numerical values. So suppose Rahul has 15 book and 4 pens. So how we are going to represent here 15 book and 4 pens. So we will be presenting it like this. 15, 4 and close. So this is the matrix here. This first 15 is representing number of books and this 4 is representing number of pens. So this 15 first value is representing number of books. How many books or this horizontal line? This is Rahul. So how many books Rahul has? 15 books. How many books Rahul? How many pen Rahul has? 4 pens. Now someone gonna ask me that, sir, why are you writing like this? You can also write it like this. Yes, we can write like this also. In this case, this will be the value of like number of pen, and this will be the number of books. So instead of books here, it was before, so it will be pen here now because it is 4 here. 4 is representing number of pens, so we will be writing like this in this case. So these are both matrix representation. Now let's talk about the bigger matrix. We will make it more bigger. Here we are taking 2 values. Now let's take some like 9 values. Suppose Rahul has, like before, Rahul has 15 book and 7 pens. Now Ravi also has 14 book and 6 pen, and Ram, he also has 13 book and 7 pens. Suppose it's 4 pen. So how we are going to represent it? So first we will be writing this rectangular bracket. I already said you that whenever we are talking about, we are going to see in the matrix this rectangular bracket. So first we will write this one 15, then 7, 14, then 6, 13, then 4. So now understood what are these values are representing, how these are representing. So these are the horizontal line and these are the vertical lines. These are the vertical lines and these are the horizontal lines. So horizontal lines are representing Rahul, Ravi, Ram. So this first one representing Rahul, and second one is representing Ravi, and this third one is representing Ram. And this vertical line are representing books and pen. First one is representing book and second one is pen. So book and pen, Rahul, Ravi, Ram. These are the representation of each horizontal line and vertical lines. Now this representation is making me to easy to access the values. Suppose I want to find how many books Ram has. So how I am going to find this? So first we are talking about Ram, so I will go to Ram here. And second I will talking about the books, so I will go to books. Now I will do like this and this. Where they are getting? They are 13. So how many books Ram has? 13 books. Suppose if someone gonna ask me how many pen Ravi has, so I am gonna first Ravi, then pen. So if we do like this, we are getting it 6. So Ravi has 6 pen. So it is making us too easy to access the values we are trying to find. So now we got the intention of the Matrix, what is matrix? It is representing in a rectangular bracket. There are some numerical values, it may be function. So we are going to define now matrix. So how we are going to define? Let's understand. So let's define the matrix. So what is the matrix? So matrix, it is a ordered rectangular. It is a ordered rectangular. It is a ordered rectangular representation of numbers, or maybe it may be functions also. So let's take example. I already talked about numbers. So let's take an example about functions. Suppose this is the matrix x square, x, root x and 2x. These all are functions. So this matrix is made with the functions. Suppose numerical, we can take 2, 4, 5, 6, 7, 8 like this. This is the matrix in numerical form. Both combination of both, it will be like this: 2, 2x, root x, 4. So this is the combination of numerical and functions also. So these are the example of matrix. Now we got the definition of matrix and some example we have seen. Now see, before we were taking about these are horizontal line, these are vertical line. Now let's define these lines, because always saying horizontal or vertical, it is not good. So let's define. Instead of saying horizontal or vertical line, we are going to say this row and column. So how we are going to do that? So let's see. Suppose this is the matrix: 2, 3, 4, 5, 6, 8, 7, 11 and 10. So this is the matrix. Before I was saying this is a horizontal line, this is a horizontal line, this is a horizontal line, and this is the vertical line. Now horizontal lines are, I'm going to say these row. This is also row. Horizontal lines are row. These horizontal lines, these are row. So I'm going to say these are row, and these vertical lines, I'm going to say column. So these are column. So these horizontal lines are representing rows, and these vertical lines are representing column. Now see, we have seen the representation. So using rows and column, we are going to write the dimension of this matrix. It means order of this matrix. So we are going to define order of a matrix. So what is order? Let's erase it. So order of matrix. Order of matrix. It is defined as m cross n. Order of matrix is defined as m cross n. And what is m and what is n? Let's understand. M is number of rows, and n is number of column. And see, m is representing number of rows, n is representing number of columns. And where we are going to represent it in the matrix, we are going to write it like here. In the base of matrix, here in right this corner, we are going to write order of matrix. And what is m? Number of rows, and n is number of columns. So let's find the order of this matrix, which we are written here. So let's find the number of column and number of rows. Then we will be finding the order of matrix. So how many rows it has? Rows mean m. So it is representing, because it is representing number of rows. So how many rows it has? 1, 2, 3. It has 3 rows. It means m is equal to 3. Now n, what is the n? N is number of columns. So we are going to count the columns. So first column, second column and third column. How many columns it has? 3 columns. So what is the order? Instead of m, we are going to write 3. Instead of n, we are going to write 3. So this matrix has the 3 cross 3 order. See, 3 cross 3 order. Now, see a interesting thing. If you multiply m cross n, what we are going to get? We are going to get the total number of element of the matrix. It means how many element matrix has. If you multiply these 3 cross 3, so then we are going to getting a value. That value will be representing how many elements this matrix has. if we multiply m cross n, here what is value of these? 3 cross 3. So how, what is we are gonna do? What is we are gonna get? 9. 3 cross 3, 3 times 3, it is 9. So it is representing number of elements that this matrix has. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. See, this matrix has 9 elements, and we are getting here also 9. So it is representing number of elements if you multiply m cross n. So let's talk about some more matrix. We are going to find orders of them. So what is the order? Order is m cross n, where m is rows, number of rows, and n is representing number of columns. So let's find the order of this matrix. Suppose this is the matrix 2, 4, 5, 6, 7, 8. This is the matrix. Suppose this is another matrix 2x 1, 4, 2, 1, root x, z 5. So what is the order of this matrix? How we are going to find it? So first, second, 2 rows. So how I'm gonna write? Row into column. What was it? M into n. What is m row and n column? So first I'm gonna write the number of rows cross number of columns. So first I count rows 1, 2. 2 rows, so I'm gonna write 2 multiplied by columns. How many columns it is? 1, 2, and 3. 3 columns it is. So I'm gonna write 3. So what is the order of this matrix? 2 cross 3. If you multiply 2 cross 3, what I'm gonna get? 6. So this 6 is representing number of elements. First, second, third, 4, 5, 6. So this has 6 elements. Now in this matrix, if I count row, how many rows I have? 1, 2, 3. 3 rows. And how many columns I have? 1, 2, 3. 3 columns. So this is a 3 cross 3 matrix. So how many elements it has? 3 cross 3 if I do. 3 times 3, what will be? 9. So 9 elements it has. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it has 9 elements. Now we got the order, we got the definition of matrix. Now let's talk about the classification of matrix. What kind of matrix we are gonna see? There are some kind of special kind of matrix. So let's classification of matrix. Type of matrix. Type of matrix. So type of matrix. First, we are going to talk about row matrix. What is row matrix? So in row matrix, there will be only one row. So in row matrix, there will be only one row. So how we are going to represent? Suppose example 2, 4, 6. This is a row matrix. See here only one row. If I write the order of this matrix, it will be one row, one cross, 1, 2, 3, 1, 2, 3, 3 columns. So 1 cross 3 matrix. So in general form, I can write row matrix will be in this form: A, I, J. It will be 1 cross n. See, what is this I representing? Element row, and this J is representing column. So first, if I am suppose, or this is the column, this is the row. In this example, I am saying that it has only one row and 3 columns. So this is the row matrix. And what is this Aij representing? It is representing individual element. So let's understand what is Aij representing. Suppose this is the matrix 2, 4, 3, 5. If I am talking about I12, what is value of I12? I am going to find first, this is representing row, this is representing column. So I am going to find first row. What is first row? This is the first row. And second column, this is the second column. If I close this one, what I am going to 4. So 4 will be the value of this element. A12 is the fourth number. Sorry, 4 value of this element is 4. If I am talking about the 3, sorry, here will be 2, 2. So this 2 is row and this 2 is column. So what is the value of A22? So let's count second row. First and second, this will be the row, and column, second column. First and second, this will be the column. So what I am gonna get here? 5. So value of this is 5. So Aij is the individual element we are talking about of matrix. So now we got the definition of row matrix. What is the row matrix? There will be only one row. column, it doesn't matter how many columns it has. Suppose it has 2 columns, you can write like this. So what is the order of this matrix? 1 row. How many columns? 1, 2 columns. So this is the row matrix, this is the row matrix. In general form, I can write it like this. There will be matrix in this format. Aij 1 cross n. This will be in this format. See, Aij is representing individual element and 1 is row because it has only 1 row, and n it can be anything because columns. Anything means natural number from 1 to like this. So we got the definition. This is a general representation of matrix. If I want to represent a matrix in general form, so I can write like this. Now we are talking about column matrix. We got the row matrix. Same, it is the column matrix here, but the difference is there will be only one column matrix. It will have only one column. So matrix that has only one column, that is called column matrix. So example, column matrix. For example, we can take 1, 2, 3. Now let's write the order of this matrix. What is first, second, third? It has 3 rows. So 3 rows and only one is column. So see, it is one column only. So it has only one column. It means it is a column matrix. In general form, I can write like this. Aij, it is general element, and what will be the order? Order will be in this format, m cross n, m cross 1. So this is the representative number of column, so it is 1. So this is the general representation of column matrix, and this is the example. Let's take another example. You can take also like this, x, x. So how many rows it has? 1, 2. 2 rows, and column, 1 column. So it is also column matrix. Now we got the row matrix, column matrix. Now let's talk about the square matrix. What is square matrix? Now it is the important concept. We are gonna talk about a lot. Square matrix is very important in matrix because it is very important. We are gonna talk about it a lot. So square matrix. Square matrix. When order of matrix is suppose order of matrix is m cross n, then it will be square matrix is m is equal to n. If m is equal to n, then it is called square matrix. Let's take an example. Suppose 1, 2, 3, 4. Now let's find the order of this matrix. If this is the order of this matrix, if m cross n is the order, if m is equal to n, then it is a square matrix. Suppose it has, let's find this matrix order. First, it has 1 and 2 rows. 2 rows, 1 and 2 columns. See, m is equal to 2, n is equal to 2. So m is equal to 2. So it is a square matrix. M is equal to n. So it is a square matrix because same number of column it has, same number of rows it has. See, it is also looks like a square. See. Now let's talk about this matrix. Suppose this is the matrix, another matrix. 1, 2, 3, 4, 5, 7. What is, how many rows it has? 1, 2. 2 rows into how many columns it is? 1, 2, 3. 3 columns. So is it a square matrix? No, it will not be because m is equal to 2, n is equal to 3, and m is not equal to n. So this is not a square matrix. This is the square matrix, this is not. So this is the importance of square matrix. It has the symmetric form. So a lot of use scenarios are there, but in rectangular form it is not symmetric. So we are going to use it very less. Like very rarely we are going to use. Most of the time we will be talking about the square matrix. Now let's further see what is diagonal matrix. Now we got the definition of square matrix. Now let's talk about the diagonal matrix. What is diagonal matrix? Fourth, diagonal matrix. So there will be two conditions. First, every diagonal matrix is a square matrix. So first it will be a square matrix. It will be a square matrix. Square matrix. And second condition is all the element all the elements other than diagonal are 0. So what is meaning of this? So this is we got what is square matrix, we already learned. Now we are gonna see what is the meaning of diagonal and what is the meaning of all the other elements other than diagonal. All the elements other than diagonal. So what is diagonal? Let's understand first. Suppose this is a matrix. 5, 6, 7, 8, 9, 10. See, here I made a square matrix because we are talking about a square matrix only here. So what is the diagonal? All the elements, these elements. See, this is the diagonal. In rectangular, suppose this is a rectangle. What is the diagonal? The line this line is called diagonal. So here also like this. This is the rectangular. Looks like rectangular. So this will be the diagonal. So these elements are called diagonal elements. In general form, how we are going to represent all the elements Ij are called diagonal elements. These Ij are called diagonal elements if I is equal to j. So these are called diagonal elements. See here for this element, it is first row, first column. So it will be A11. And this element is second row, second column. It will be second 2, 2. And for this element, it is third row, third column. It is A33. So these are called, see, in these all elements 1, 1, 2, 2, 3, 3. So all the elements of the form where I is equal to j are called diagonal elements. So in this matrix, what are the diagonal elements? 2, 6, 10. What I am talking about? All the elements other than diagonal are 0. It means these elements other than these elements, if all other elements are 0, then it is called diagonal matrix. Let's take an example. Suppose this is the matrix 2, 4, 5, 7, 8, 9, 10, 11, 12. So what are the diagonal elements? These are the diagonal elements I am talking about. And other than all elements are 0, suppose these all elements are 0. If these all elements are 0, this is 0, this is also 0, and this is also 0. See, all the elements, these are 0 with diagonal elements